Okay, for this question we're being asked to solve the equation sine squared 3x minus sine squared x is equal to the sine of 4x for x between 0 and pi. And it's worth noting that the word solve here means that what we really need to do is find all the values of x, where x is between 0 and pi, that make this equation true. Now the first thing to note is that on the left hand side of this equation we've got the sine function to the power of 2, so we've got sine squared of 3x minus sine squared of x. Yet on the right hand side we've only got the sine function to the power of 1, so it's just sine of 4x. And what would be really helpful in solving this equation is if we had the same power on both the left hand side and right hand side. And in that vein, it's worth noting a really handy result, which is that the sine squared of some angle alpha minus the sine squared of some other angle beta is equal to the sine of alpha plus beta multiplied by the sine of alpha minus beta. And notice in this result that we've got the left hand side having sine squared and the right hand side only having sine to the power of 1. So exactly what we're after. Now if this result is not something that you're familiar with, if it's new to you, I do prove it in a prior video. So I'll provide a link to that so that you can have a look if you need to. But for this video, I'm just going to take this result as given. So really what we're doing is wherever we see alpha in this result, we can insert 3x, and wherever we see beta in the result we can insert x, and that's another way we can restate the left hand side of this equation. So let's go and do that. So therefore really what we're being asked to do for this question is to solve, and for our left hand side I'm going to restate that as sine of alpha plus beta, or in our case 3x plus x, multiplied by the sine of alpha minus beta, or in our case 3x minus x. So that's our left hand side restated in terms of sines to the power of 1. And then we're wanting to know when that is equal to our right hand side of the sine of 4x. So from there we can rewrite that as the sine of 3x plus 1x is 4x, multiplied by the sine of 3x minus 1x is 2x, being equal to the sine of 4x, and that looks like a much more palatable equation to solve. Now, at this point many students might be tempted to see the sine 4x on both the left hand side and right hand side and think, maybe I can just divide both sides by sine 4x and then I'm left with something really nice, just the sine of 2x equals 1. But we can't do that. We need to really not give in to the temptation of doing that, because in our domain of x being between 0 and pi, it could very well be the case that the sine of 4x is equal to 0. So if we were to divide both sides by sine of 4x, we're effectively dividing by 0, and that's not mathematically defined, so we just can't do that. So really what we need to do is, really the best thing we can do is bring the sine 4x over from the right hand side to the left hand side. So in other words, subtract sine 4x from both sides. That way we'll have a right hand side of 0, and then we can make use of the usual techniques of when we've got things multiplied being equal to 0, then it means each item will be equal to 0. So what we'll do is we'll subtract both sides, we'll subtract sine 4x from both sides, so therefore really what we're doing, the equation that we're solving is the sine of 4x multiplied by the sine of 2x minus the sine of 4x. We want that to be equal to 0. And at this point, let's factor out our 4x. So we'll have the sine of 4x multiplied by the sine of 2x minus 1. We want that to be equal to 0. And now we can say, therefore, really this will be true when the sine of 4x is equal to 0, or the sine of 2x minus 1 is equal to 0, or in other words, the sine of 2x is equal to 1. And these are fairly straightforward equations to solve. We could probably even just sketch up the curve of sine of 4x and see all the points where that curve is 0. And we can sketch up the curve of the sine of 2x and see all the points where that curve is 1, remembering that we're always doing it for the domain of x between 0 and pi. So maybe we'll do that now. So step 1, let's plot the curve of the sine of 4x. So I'll just get out a ruler and let's draw up some axes. So that'll be our y-axis there, and we'll just have an x-axis. So we're going between x between 0 and pi. So maybe we'll just call, we'll have our x and y axis and 0, and we'll call this pi. So this will be pi on 2. And I'll just split each of those, noting the nature of the sine curve. So if you're familiar with the curve of sine x, you'll know that the curve of sine x has a full rotation, or it goes through its full shape between 0 and 2 pi. That means the curve of sine 4x will go through its full rotation between 0 and 2 pi on 4, or in other words 0 and pi on 2. So actually I'll just also note 1, a y on the y-axis, 1 and negative 1. And now we can draw sine 4x as coming up from 0 and then turning and coming back down, then hitting negative 1 and getting back to 0, all between x is equal to 0 and x is equal to pi on 2. And then the curve will have another full rotation between there and pi. So in terms of when does that curve hit y is equal to 0, or the x-axis, that happens at x is equal to 0, x is equal to pi on 4, x is equal to pi on 2, x is equal to 3 pi on 4, and x is equal to 4 pi on 4, or pi. So that's worth noting. So we'll say sine of 4x is equal to 0 when x is equal to 0, pi on 4, 2 pi on 4, or in other words pi on 2, 3 pi on 4, and then 4 pi on 4, or just pi. So there's 1, 2, 3, 4, 5 solutions when sine 4x is equal to 0. And it's worth re-emphasizing back up at this point here, if we had made that mistake of just dividing both sides by sine 4x, we'd both be dividing by 0, which you can't do, and we'd also be missing out on these 5 solutions, because these are solutions to the original equation that we just would have totally disregarded. So that's dealing with this first part of the rearranged equation. So that's dealt with there. So now let's take a look at the second part, the sine 2x minus 1 equals 0, or in other words sine 2x is equal to 1. So let's draw up the curve of sine of 2x and see all the places where that curve hits the value 1 in our domain. So let's do that. So we'll have the curve of sine of 2x, and again very similar structure, so I'll just draw up my axes. Oh. Okay, so we'll have our x-axis, our y-axis, intercepts at 0. I'll call this pi on 2. Call this pi, and so that would be pi on 4 and 3 pi on 4. We're concerned with our y values of 1 and -1. That's where the curve hits. And here, again, we know that the sine x curve does a full rotation between x is equal to 0 and 2 pi. So the sine 2x curve will do a full rotation between x is 0 and 2 pi on 2, or in other words, between x is 0 and pi. So let's draw that up. So we'll start at 0. Oops, undo that. We'll start at, we'll get our blue pen. We'll start at 0 and we'll come up, loop around, come back down, then we'll hit -1 and then come back to pi, and there's our full rotation between x is equal to 0 and pi. And remember here we're concerned with when this curve is equal to 1, and within our domain that really only happens at one point. At this point here, x is equal to pi on 4. So therefore we can say that sine of 2x is equal to 1 when x is equal to pi on 4. So that dealt with this second element of the equation. And notice that this one solution that we get from when sine of 2x is equal to 1 actually overlaps with one of the solutions from sine of 4x equals 0. So nothing was added here, but just for completeness it's still important to do. And also really important to re-emphasize that if we had made this mistake up here, if we had given in to the temptation and divided both sides by sine of 4x, we would have only gotten 1 out of the 5 solutions that we needed. So again, really re-emphasizing just how careful you have to be there. But that's pretty much all the work we need to therefore conclude that the solutions to our original equation, which was sine squared 3x minus sine squared x equals sine of 4x. So the solutions to sine, let's make sure we got our pen, sine squared 3x minus sine squared x is equal to the sine of 4x. The solutions to that equation for x being greater than or equal to 0 and less than or equal to pi are, and we can just list them out, they are x is equal to 0, x is equal to pi on 4, x is equal to pi on 2, x is equal to 3 pi on 4, and x is equal to pi. And it's really just good discipline to write out this final conclusion, just to make it really clear to whoever's working through your mathematical working that you have made the link that the solution to this rearranged equation is equivalent to the original equation that we were concerned with. So there you have it for that question. Quite an interesting one. I think the essence to being able to solve this was being familiar with this result here, which again, if you weren't familiar with it, I'd suggest going and taking a look at the prior video that I've made on that derivation. It may not be the most common result going around, but again, even if you didn't know it, you could probably get there making use of more basic trigonometric identities. It just take a bit more work. But knowing this result from scratch really kind of minimized the amount of effort we had to do here. But really in terms of technique, the key was in thinking about the power on the left-hand side and the power on the right-hand side, and knowing that we really wanted those to be the same power to make our life easier. And then it's just a matter of familiarity with the sine curve and how it works with different periodicities. And you basically get there, and really the key is making sure you get all the solutions, not just one of them. So hopefully that all made sense and you found that helpful, and tick boom.